Hi, PackagingCon. Can you hear me? Really great to be here. Yeah, so I'll be talking about PyPI supply chain security, but quickly, let me just tell you a little bit about who I am. If you don't know me, I'm Dustin. I'm a developer advocate at Google, where I focus on Python, developer tools and experience, and some open source security projects as well. I'm also a maintainer of the Python Package Index and a member of the Python Packaging Authority and chair of the packaging working group for the PSF. And I'm a director of the Python Software Foundation. So a lot of things to talk about here today with regards to Python and PyPI and packaging security for the Python ecosystem. I want to give you just a quick overview of the PSF, like what it is and its projects if you're not familiar with it, sort of how the organization works. And then most of the time I want to spend talking about some recent packaging projects that we've had success with and some progress projects as well. I also am excited to give a kind of a sneak peek at a new tool that's now available. And I also want to talk a little bit about some future potential products, some stuff that we envision might be interesting in the near future. So first, yeah, what is the PSF? So the Python Software Foundation is the 501c3 nonprofit responsible for many projects around Python and the Python ecosystem. It's founded in 2001, and we have about $3.1 million in revenue per year. The PSF is run by a mix of folks, so partly by paid staff, partly by its board of directors, and partly by volunteers. So we have 8 paid staff, which include accountants, folks that work full-time on our infrastructure, folks that are on our event staff. We have an 11-member board of directors. That's what I'm on. We are all volunteers. And we also have a 5-member steering committee. These are the folks that are directly responsible for overseeing the Python, the language itself. There are a few key projects of the PSF. So like I mentioned, Python, the language itself. CPython is probably what you're most familiar with, and this was created around 1991. PyCon US shortly followed in 1993. This is one of the largest Python conferences in the world, and it's also a very large portion of the PSF's income. It also didn't happen the last 2 years, or rather, it didn't happen in person, it happened virtually. And one of the last projects of PSF, and one of the ones most near and dear to my heart, is the Python Package Index, which was created in about 2002 to help distribute third-party and open source Python code. This is the canonical repository, essentially, for all Python packages and distribution of Python code. It generates 0% of the PSF's income. It does not produce any income at the moment, but it is approximately 95% of PSF's liabilities. It has a very large bandwidth bill that is kindly donated to us by an infrastructure sponsor every month, as well as other bills along with storage and compute resources and things like that. And we're always trying to add features to it as well, which don't come free. So to give you a sense of the scale there, PyPI serves more than 900 terabytes per day, more than 2 billion requests per day, and total costs are about a little more than $2 million a month if we take in the kind of fair market value for all of the infrastructure that we have. We don't pay that much a month because we have some very generous donors, including like Fastly, Google Cloud, AWS, and many others. If you are interested more in what powers PyPI today, there's a post that I wrote a couple months ago about as an update to one from many years ago on the current status of what it takes to keep PyPI up and running on a daily basis. So yeah, I want to go through a couple recent projects that you might not be aware of and sort of describe a kind of a funding and feature development model that we are sort of pursuing and has been working well in the past. And also sort of raise awareness about a couple of like really nice features that now exist on PyPI that weren't there before, but were built with the help of some volunteers and some paid staff and some generous donors and sponsors. So the biggest one and kind of the first one was we did a full stack rewrite of PyPI. This was implemented and finished in about 2018. And this was done, the kind of final push on this was done with $170,000 given to us from Mozilla via the Mozilla Open Source Support Program. And the most visible part of this was that PyPI went from looking like this to looking like this. And it wasn't just a front end rewrite. PyPI is one of the oldest software repositories, and it was a legacy system basically at this point. It was kind of on life support. It was kind of hard to maintain. It didn't have great test coverage, that kind of stuff. And it wasn't using kind of like modern tools and frameworks. We created PyPI before any of the software on PyPI existed, so it kind of had to bootstrap itself in that way. The new modern PyPI is like essentially a modern web application with a lot of other features built in that make it much more maintainable and sustainable, and also generally cheaper to run as well. It basically has complete feature parity with the old PyPI and then allows us to develop more interesting and new stuff on top of it. After that, we sort of went on a path of adding some important features that had been missing from the old PyPI. So one of them was around accessibility and generally access to PyPI. This is with a $76,000 grant from the Open Tech Fund. And this allowed us to do some internationalization and localization of PyPI. So PyPI is now translated into like 13 different languages, which is incredible. It also allowed us to build support for API tokens. So prior to this, if you were uploading an artifact to PyPI, you had to do basic HTTP authentication with your username and password. And now you have the ability to produce fine-grained API tokens for individual projects and individual permissions. And this also added two-factor authentication, which didn't exist on PyPI before that either, either via TOTP or WebAuthn as well. So kind of bringing PyPI's general security into the modern age, but also just making it a lot easier to use and access and do various things that are in its wheelhouse. Oh yeah, here are the 13 languages, which are, by the way, all translated by volunteers. So kudos, this is really awesome. And these languages include Esperanto. With $100,000 from Facebook, we built a prototype malware detection system. So malware, and I'll talk a little bit more about this later as well, is kind of an ongoing problem with PyPI, and I'm sure you've seen stuff in the news, folks making kind of a big deal about essentially publishing all sorts of random and not useful stuff to PyPI. And the way I see that, this is kind of a win for PyPI, actually. For a long time, Python packaging and PyPI was sort of held up as something that was too hard to use, essentially. And we've been slowly chipping away at that. And I've gotten to the point where actually it's fairly easy. And I see people complaining that it's almost too easy to publish to PyPI. So that's a good thing, because we want users, and especially new users and folks that are less familiar with Python, to be able to publish to the Python ecosystem. But that comes with some downsides as well, including spam, which is unfortunate, and malware, which can sometimes be harmful. In practice, I don't think it has, we've not really had any significantly bad malware attacks that have harmed users, but the quantity of things that resemble malware and spam on PyPI is significant and is generally a burden on maintainers' time. So anything we can do to improve the ability to detect these is generally good projects to focus on. This is a huge one. So with $200,000 from Mozilla and $200,000 from the Chan Zuckerberg Foundation, we did a complete dependency resolver overhaul of pip. And this also includes some UI UX studies and testing. And you might not really know what this means. You might not have really had an experience of this changing out from under you if you're a pip user. But if you are familiar with the Python ecosystem and pip itself, you'll know that this was an old issue. This is something from 2013 we identified as a problem in pip, kind of a core part of pip, how it determines which dependencies should be installed given a certain set of constraints. And it was less than ideal for a very long time and caused a lot of problems as a result. So with the help from these organizations, we were able to essentially completely gut and rewrite and rebuild a better, correct dependency resolver for pip, and also make general usability improvements along the way as we did it. And this issue is now closed. This issue is a thorn in pip's side for a long time, and is finally closed, and we were able to move on to greater and better things. And another project that wrapped up recently with support from Google is focused on highlighting open source vulnerabilities. So these are vulnerabilities that are published via CVEs or via other means. We created a community database that is owned by the Python Packaging Authority to sort of centralize all of these for the Python ecosystem. But then we also integrated this via the open source vulnerabilities project into PyPI. So now vulnerability information about projects on PyPI sits alongside the projects themselves and can be viewed in the API. And more on that in a second. And that looks like this. So it's just a database of all the vulnerabilities that's community maintained. Anyone can contribute to it, and it's up and running. and that's pulling in stuff from OSV. All right, in progress projects, and this is really the most exciting stuff, I think. So one thing we were able to do with support from Bloomberg recently, we hired a Python packaging project manager for a 2-year contract. And this is Shamika Monahan, and she's just getting started, but working on generally overseeing all of the projects that I just described and I'm about to describe in this space. So having a dedicated project manager is super important here to keep engineering on track, keep volunteers on track, and just maintain continuity between the projects and the PSF and everything around there. So thanks to Bloomberg for this. With support from Google, we were able to hire a CPython Developer-in-Residence, which is something that the Python Steering Council and the PSF have been wanting to do. This is essentially someone hired full-time for a year to work on CPython and CPython alone, which is something that we've never had before. Sometimes folks have been sponsored by their employers to work on CPython. This is the first person hired by the PSF independently to focus on some of the things that a volunteer might not want to do, like burn down the issue tracker and review old stale PRs and also land important features as well. So the CPython Developer-in-Residence is Łukasz Langa, and he's been doing an amazing job posting weekly updates on everything that he's done. And I would encourage you to go and look and read at some of the stuff he's done. It's been really incredible. And another project in progress is doing repository signed metadata. So this is via the Tuf protocol with a grant from Facebook and the NSF. Folks from NYU, VMware, and a couple other organizations are working on implementing Tuf for PyPI. So this means that secure PyPI downloads and repository metadata is signed by the repository. And this is essentially implementing PEP 458, which was described a long time ago, but long term, they will also be integrating Tuf support into pip and some other important installers in the ecosystem as well. And this is one that we've been working on very recently. It's vulnerability audit tooling for our Python ecosystem. This is with support from Google. We developed some community-owned tooling for Python vulnerability auditing. We developed a prototype with Trail of Bits, which is a security consultancy. And we have a planned stable release of this tool on December 1st. However, I have a sneak peek for you, and I want to show you a little bit about this. It's not really a sneak peek because actually this is available on PyPI now. So you could go and install it now. I just wouldn't consider this release to be stable. And generally, the project is a prototype, but I want to give you kind of a little overview of how it works, what it uses, and you can go and install it now and run it on your machine and see if you have any Python vulnerabilities installed. So it's available on PyPI, like I said. It uses the vulnerabilities from the advisor DB that I mentioned before. And that's either via the PyPI's JSON API or via the OSV API. It supports auditing your local environment, or you can pass it a requirements.txt file and it will audit that instead. And it uses pip under the hood, although Prajan, if you're watching, it does not import pip's internal API. So it might be fun to figure out how that happens. And so some examples of how you'd use this, right? You could just run it on your local machine. It will tell you if there's vulnerabilities installed or not. Pass it a requirements file for an application that you're trying to install. And it would tell you if there are any vulnerabilities that would be installed if that requirements file was to be installed. It will basically tell you about every known vulnerability that exists in the vulnerability database. So for example, if you have this version of Flask installed, it would warn you that there's 2 known vulnerabilities about that version, and on, give you an extended description, give it to you in JSON format. And like I said, this work is not done yet. We're planning for a stable release on December 1st, which will include all of those working features that I just mentioned. But some future work that could be done here as well is auditing other requirements formats like pyproject.toml or pipfile.lock or sort of other things in the space, auditing static container images, outputting the results in other formats besides JSON, perhaps in like SBOM, supporting automatically fixing vulnerable environments, right? If I find a broken dependency, I just run pip audit, or if I find a vulnerable dependency, I just run pip audit fix, and it will either upgrade me to the current working version or uninstall the vulnerable version, whatever makes most sense, and much more. And I want to give a quick shout out to William Woodruff and Alex Cameron at Trail Bits, who've done the majority of the work on this project and have done a really nice job and focusing on making it super usable and make sense to developers as well. All right, and in the last 5 minutes, I want to talk about some future potential products. This is stuff that is not necessarily in progress right now, but would be a huge win for the Python ecosystem. So like I said before, malware is an ongoing problem with PyPI, And really one of the biggest problems is that it gets us in the news a lot and casts us in a negative light. So like I said, anything we can do to improve the situation around malware not only makes PyPI more reliable, but also potentially protects our users. So obviously we can't catch all potential vulnerabilities in all malware, but there's a couple of things we could do here. So right now, PyPI does zero introspection of a package on publication. You basically upload an artifact to PyPI and we publish it, and that's the end of the story. We can't necessarily do any kind of like malware detection in band that potentially block an upload or slow down an upload, but we could do a lot of stuff out of band, right? And we do have some third parties that are currently scanning PyPI and sending in vulnerability reports when they detect something, but it's a little bit lossy and a little bit noisy and relies on volunteers to solve these problems. So introducing some higher grade tooling around this, or potentially working on a consensus of trusted third-party scanners to find and detect malware and quickly remove it from PyPI would be a really interesting and impactful project to land here. Another one is a big thing in the news is dependency confusion. This affects not only PyPI, but other packaging ecosystems as well, like NPM. And this basically is when folks have internal private repositories and external public repositories, and they're sort of mixing dependencies between the two, there's potential for what's called dependency confusion, which would be installing something from a public repository that you intended to install from a private internal repository and becoming vulnerable as a result. So the big thing that the Python ecosystem can do to fix this here is namespaces. There's a lot of things that already exist that can be done to fix this as well, like hashing and pinning and things like that. But namespaces would go a long way as well. Right now, all packages on PyPI exist in one single global namespace. That would be like if GitHub didn't have organizations, and that's kind of madness, right? It doesn't bode well for knowing which projects can be trusted, or sort of restricting the projects you intend to install based on organizations that you trust. So right now, packages have sort of implicit namespace prefixes, like Google Cloud prefixes most of its packages with Google Cloud. But this isn't enforced. This is kind of just something that they do for their own sanity. And introducing namespacing would remove the ability, or potentially reduce the ability, for things like typo squatting, dependency confusion, all those kinds of classes of attacks, because you would be able to restrict what could be published under that namespace based on who owns that namespace and what organization it belongs to. Another thing that was recently announced that's super exciting, GitHub is now supporting OpenID Connect OIDC for GitHub Actions, which means that each GitHub action now has a short-lived token that can identify that action uniquely and securely. How could that be useful? So if PyPI were also an OIDC provider, this means that GitHub and PyPI could federate to share authentication information between each other. And this means that you could potentially use credentialless publication from GitHub Actions, publish to PyPI from GitHub Actions. So maybe as part of your CI system, you have a GitHub action that runs a build on PyPI and publishes it. This would remove the need for storing passwords, API tokens, that kind of thing externally as well. So this would be super exciting to see. And more. So there's another PEP 480, which is about end-to-end package signing. Landing this with ephemeral keys using short-lived certificates and OIDC would be super interesting. This would allow us to root verification in the developer's actual identity on a service like PyPI, and not in something like a PGP web of trust. And this is a big one, but I really love this comment. Everything on PyPI is just random artifacts uploaded by whoever ran a build script on their machine. So even if you have permissions to upload to PyPI, you're kind of just doing it wherever is most convenient for you. And that doesn't mean that you're using best practices or that it's actually verifiable. So this is kind of several parts. One is reproducibility by default, making Python packages, both source and built distributions, reproducible across the entire ecosystem. This is made challenging by some features of Python packaging, like using setup.py, but it is possible. And tying artifacts to a mutable source, like a commit on GitHub, would help us derive source distributions from actual source repositories as well. Another part of this is verified reproducibility. So once we have reproducibility, multiple independent build pipelines can then go and verify that a build on PyPI is actually reproducible. So this would mean that we could go from an actual source repository and a commit hash to an actual source distribution on PyPI that can be verified by multiple entities, and then go to built distributions as well. And that becomes challenging because built distributions can be built on many platforms, but it's a step in the right direction, I think. And finally, this begets like, if we have the ability to reproduce builds, why not have a canonical build and publish service? One of the problems of all these new security features that we are interested in introducing is actually getting people to adopt them. So if we had a service that was the de facto standard for publishing to PyPI, either it's a GitHub action or it's a hosted service by the PSF or something like that, this means that everyone could sort of get these benefits right out of the gate and not have to worry about building custom build pipelines, building things on their local machine, that kind of stuff, and much more. So there's a long list of fundable things that I didn't mention on this repo here that the Python packaging improvements team maintains. And also, if you stick around later in this track, Matthew Suzo is going to give a talk on securing the supply chain with Salsa, and he'll talk a little bit about what that means for the Python ecosystem as well. If you haven't heard of Salsa, I would definitely recommend watching that talk and seeing what could be done there. And thanks. If you want to sponsor our work, check out pypi.org/sponsor. You can email me di@python.org or follow me on Twitter @di_codes. And with that, happy to take any questions that might exist or say hello. Is there a host there?
Yep.
Hey, Jay.
Hey, Dustin, how are you? It's really interesting. So let me see there. So I think one of the big questions about pip audit is like, how, when you build wheels, how would you go and inspect all the things inside a wheel?
Right. So the way pip audit works is, we have a known set of projects on PyPI, and we have a known set of vulnerabilities that refer to those projects on PyPI. So if you have a wheel installed on your system, pip audit and pip are able to determine A, that you have that project installed, and B, what version of it is installed. And then pip audit then essentially goes and does some checks, like, do we have a known vulnerability for this project at this version? So it's less about, actually like scanning artifacts for, credential exfiltration or something like that. More about like known vulnerabilities that have been reported by these projects or about security researchers.
I've got a question in the chat. With the cost required to maintain PyPI, would you consider a monolithic centralized registry a sustainable way to distribute software to the commons? Does the PSF have a contingency plan? I guess the PyPI have a contingency plan for handling costs if the infrastructure donor receives funding?
Yeah, and there's some long-term stuff in the works here about making PyPI generally more sustainable, and a lot of that burden of the high bandwidth consumers are borne on a very small set of folks. So one of the things the PSF is exploring is how can those people better support and the resources that they're consuming. But the other question was, kind of hinting at like, well, should PyPI be a central source of traffic? Could we distribute the load somehow? And actually, I think this gets brought up a lot, and maybe it's time to revisit it. But a while back, PyPI did support federation between multiple PyPI mirrors, and it was a mess. Like, it was extremely hard to maintain. You had to spread trust across multiple, independent implementations of something that resembled PyPI, and it became really challenging. So these days we have better tooling technology. Something like that could be explored, but right now there's a lot of value in having a single centralized repository. So yeah, right now that doesn't outweigh the current like estimated cost, but yeah, something we're thinking about long term.
Okay. I'm just in interest of keeping us on time. We'll do one more question. Why not use a PGP style web of trust?
Yeah, so if you're interested in learning why we currently support uploading signatures to PyPI, so you can do PGP Web of Trust today if you wanted to. If you upload a distribution, you can put a signature alongside that, and folks can do the Web of Trust and verify that themselves. The PyPI volunteers and maintainers generally consider it to be not the holy grail. There's actually a long post written by Donald Stuff that goes into much more detail about this. If you search package signing is not the holy grail, it will explain sort of like why Web of Trust is not the best, or we don't think it's the best model for trusting artifacts on PyPI. But via OIDC and key resilient signing and things like that, we actually can build trust in artifacts on PyPI without having to build a web of trust as well, by trusting PyPI as an identity provider. So I think you'll hear more about that soon in the future. But yeah, for now, web of trust, you can use PGP with PyPI now, but it's not widely used, and we have better things that we could do, I think, at this point.
Okay. All right. Thank you, Dustin. I think we'll move on to the next talk.
Sure. Thanks. Take care.